A plank of length 8 meters and mass 20 kilograms is supported in a horizontal position by a support at one end A and another at a point 5 meters from A. We want to know what is the furthest from A a child of 40 kilograms can stand. We're going to produce a diagram. The plank would be modelled by a rod, and we need to draw it horizontally since we know we're in a horizontal position. The length of this plank is 8 meters, so we know that it's 8 meters from one end to the other. We know the mass is 20 kilograms, but we don't know where it acts. Remember, the rod can either be uniform, which means the weight would act at the center, or non-uniform, in which case it may act at some other point, and in some questions we may be asked to find this point. To draw this diagram, I'm going to assume that it is a uniform rod, and therefore the weight will act at the center of the rod. The weight, remember, will be the mass times gravity. Since it's at the center, it would be 4 meters from the end. We know that we're supported by two supports, one at A and the other 5 meters from A. So if we call this end A, we'll put one support here and one support here. This support is 5 meters from A, so would be 1 meter from where the weight acts, which we know is halfway along the rod, or 4 meters from A. So 4 plus 1 gives us 5. We want to know what is the furthest from A child of 40 kilograms can stand. Clearly, they could stand anywhere between the two supports. So when we draw their position, we must draw it outside of this range. The child has a mass of 40 kilograms, so the weight will act downwards here and be 40 times g. We don't know the distance they can stand from A, so we would call it x. There would be two other forces acting. There'll be a reaction contact force at A and a reaction contact force at the other support, which we'll call RB. This is a bit like when you sit down on a chair. The four legs of the chair will push down on the ground, and the ground pushes back up on the four legs. That's why the chair doesn't go through the ground, and also why the chair doesn't leap up in the air.